Um, Hi, I'm Rakesh Ipsar. I'm in Group 3. Our topic is frequent pattern growth strategy. In this, I'll be discussing on improvement of FP growth algorithm. So we have seen how FP growth algorithm is better than other association rule mining algorithms. But also FP growth algorithm has a few drawbacks, and this could be improved by using different approaches. So a few approaches are improvement of FP growth with adjacency table, and also it can be improved by parallel FP growth approach, and using multiple minimum supports with maximum constraints. Uh, but in this discussion, I'll explain how this algorithm could be improved using adjacency table. And why improvement? So as I said, FP growth algorithm also has few drawbacks. So which are to be considered while working on dense and large item sets. So some of them are uh, it requires two scans of original database, and recursive mining of FP tree is required to generate frequent pattern, and also to create FP tree, all item sets must be required. So the FP tree should contain all of the item sets in the database. Then if frequent item sets in the database is too many, uh, then it also requires a lot of memory uh, to store the items. And then with all this, the algorithm becomes inefficient. Yes, approach. Uh, Here we'll see a approach how to improve the FP growth using adjacency table. First, we have to scan the original transaction database, but this scan is done once. So after this, we form an association relationship. This can be a complete graph. Then adopt a storage method combining the adjacency table with the hash table. So doing this will remove item sets that are less than the minimum support, and avoid generating all non-empty subsets of the largest frequent item sets. And then the last step is mining of frequent item sets. So this can be done by generating single dimensional frequent item sets, and converting it to multi-dimensional frequent item sets. Then implementation. So for this, first we have to read a database with a transaction table. So let us consider this transaction database where it has transaction IDs and the item sets. Um, Once the database is read, uh, a complete graph can be formed by considering each item sets that are related to each other. So for example, I2 is related to I3, so and I3 is related to I5, and I6 is related to I2, I3 is related to I1. So every time we add the 1 to the weight of the edge, so once the same two items are associated, the weight of the edge is incremented by 1. So you can see for few connections, the weight is more than 1, or 2, it is 3. Um, then once this graph is completed, the weight of the final edge is the association frequency. Then from this, we can create a adjacency table. So you can see I2 is connected to I3 with the weight 2. So I2 is connected to I3 with the weight 2. I5 is connected to um, I2 with the weight 2. So similarly for each node, we can form this adjacency table. With each node, we can form this adjacency table. Uh, Once this is done, we can use minimum support and remove unrelated items. So here we'll consider minimum support as 1 and remove all the nodes with the support countings of 1. So we have marked it cross for all count of 1. Then once this is done, then the next step is mining of frequent item sets. So that can get a single dimensional frequent item set. So you can see from this, we can frame this single dimensional frequent item set. So here I1 and I3 are related with count 2 and I1 with I4 with 2, and similarly for the other node connections. So some single dimensional frequent item sets are subsets of 3 frequent item sets. By mining this adjacency table further, we can obtain 3 frequent item sets. For example, so we can see here I1 is connected to I3 and I3 is connected to I4 with a weight 2. So similarly for the um, other nodes, we can frame it and have this 3 frequent item sets. And as mining continues, you can form 4 frequent item sets and so on until all the frequent item sets are mined. So at continuing this process, at last we will have all the frequent item sets that are mined using this approach. Next is experimental results. Um, yes, we can see when both algorithms, this is an improved FB algorithm with adjacency table and a normal FB growth algorithm, is run against 2 criteria. One is database size and on support count. In both these cases, improved FB growth algorithm has less runtime when compared to the normal FP growth algorithm. So we can say that improved FP growth algorithm is more efficient than FP growth algorithm in this case. Okay, then advantages and future growth. Yes, so this algorithm will reduce the input output operations. This is because this will scan the database only once, and low complexity. This is because it does not require establishment of a header file as in FP growth, and also we can avoid many sort operations here. And then as we have used hash table, so it will help us for the fast lookup, and also it avoids recursive mining. So overall, this will reduce the time and memory consumption when compared to the normal FP growth algorithm. So this could be further improved by implementing parallelization in future. Okay, this is the reference I have made for this discussion. Thank you.